I'm Wendy Hartsock, science and peptide enthusiast. Welcome to Season 2 of Exploration Science. This season, we will be expanding our scientific content as well as welcoming a new co-host, Dr. Diedra Shorty. Welcome to Exploration Science Season 2.
Thank you. I'm very excited about it.
Yeah, I'm really, really excited to have you on board as co-host. I think that you're going to bring some really awesome ideas and some new guests. And maybe just for the listeners, could you talk a little bit about what you're doing right now and maybe some of your past roles?
Let's go into my past roles first. So, in the last year and a half, I've gone from being a graduate student to a contract employee to most recently an employee at CEM, where I am working with you and the marketing team to kind of develop new strategies to bring our products to, just the general population of scientists. And so that's kind of taken me from a peptide chemist as a graduate student to working with peptides kind of adjacently. And now I'm no longer working hands-on with peptides. It's much more of a utilizing tools to make peptides, which I think is really cool.
Mm-hmm. Nice.
And so I'm very excited about that. And it's also given me an opportunity to now work with you on this podcast and kind of bring interesting science to people, which is a really fun thing to do in general. There's all types of interesting things to learn.
Absolutely. And so maybe talk a little bit about your PhD as well, because I think that it's a pretty fun story. And we can even go back to like how you got into science, but maybe just for people to know where you did your PhD and who you did it with.
So I did my PhD at the University of California, Davis, under Professor Kit Lamb. And if anybody's familiar with Kit Lamb or combinatorial chemistry at all, then you know that Dr. Lamb was one of the developers of a particular method called one bead, one compound. It's a method that utilizes split and pool synthesis to generate very large and complex libraries with an astounding amount of diversity. And so as a grad student, my job was to first of all figure out how to generate these libraries, specifically for whatever purposes I was looking for. In whatever library I'd made, then my job after that was to then screen it, synthesize those hits, and then test them, whether that be in cell binding assays or utilizing confocal microscopy to determine whether or not there's any binding occurring on different ligands. Just pretty much a very wide array of things that you could do with peptide libraries, which is the best thing about peptide libraries. It's kind of just like, okay, you make the library and you screen it for whatever you're interested in. It's a very diverse method, and I really enjoyed working with it as a graduate student. The way I got into that is that when I was much younger, from a very young age, I've known I wanted to be a scientist. I did not know what type of scientist, because as a kid, you don't know what a chemist is. You just know, I want to do science. And I didn't really figure out chemistry until I got into high school, and it was my worst subject. So I was in AP biology and I think honors chemistry, and I sucked. I could not name chemicals. It was like, okay, here's a polyatomic ion. What is the name of it? I don't know. But I could tell you all of the names of everything we were studying in biology. And it was something about that being difficult for me that inspired me to continue on with that. And that's not to say that it just got easy overnight.
Right.
In my first year of undergrad, I failed my first chemistry course. It was a very humbling experience. I failed my first general chemistry course. I struggled learning reaction mechanisms because I went to a school where the chemistry course was kind of designed more around med students. And so we weren't doing a lot of mechanisms. It was more of nomenclature and, figuring out what you need for the medical exams. And so when I got to grad school and I was doing reaction mechanisms, it was a lot. But, that kind of inspired me to keep going. And now I'm here.
Yeah. So it's funny because you and we have, very different entries into chemistry, but then also a lot of similarities. So for me, like I wanted to be a veterinarian. That's the only reason I ended up going to college, because I was like, oh, I'll be a veterinarian. And then I took biology and I was like, oh, I want to be a field biologist. And I took chemistry 100. And so I don't think I took an actual chemistry course in high school because I dropped out before I would have, I think, taken that. And so, um, so when I took my first chemistry course, it was way too much homework, and I was like, and I failed, I got F, and so I thought I hated chemistry. So I had to retake. That's again Chem 100. That's like the basic chemistry. I had to retake
Yeah.
it. Still only got a B. Got to university and took the general chemistry because I had to for my zoology degree. I had to take the up to organic, and got through Gen Chem. Okay. It was kind of like I still don't like it. And then I got to organic chemistry, and mine was they had two different courses. One for the med students and nursing students to take, and then the other one for the more scientist track. And so my teachers were phenomenal. And once I got to organic chemistry, I was just like, oh, arrows. Yes, I can get down with like moving arrows around. And then after that, like every chemistry class I took was like more and more exciting, to where I ended up doing a double major in zoology and chemistry. But it is funny to come out of this area where you think like, I'm horrible at chemistry, I hate chemistry, to I love it and I want more and more and more and more. So I think
Right.
it's kind of fun to have that, like we have such, again, similar stories, but then totally different entries. So
Right. A lot of people very frequently comment on how you could possibly be bad at chemistry and have a PhD in chemistry. I'm like, I
yes,
am a good example
example.
of that. I
Awesome.
just try really hard.
Yeah. Yes, I totally understand that. Again, and not just for chemistry. For me, it's many, many subjects. Like I just have to try really, really, really hard.
Yes.
But that's the way it is. So maybe could you talk a little bit about what your thoughts are for season two? Areas that you're interested in exploring. Maybe we'll even get some people who volunteer that they want to be on the show.
So for season two, for me personally, when I was coming in, my first thing that I needed to do was figure out what exploration and science meant to me.
Mhm.
So I understand that a lot of the things that you've done in season one were okay, this is a really cool thing, or let's talk to kids and learn about science, or let's talk about machine learning, which I love machine learning, especially in the context of science. It's very cool. Um, but for me, I just wanted to kind of figure out what that meant to me. And so that kind of leads to things that are less typical of what you'd view as exploration science. It's not necessarily, oh, what's the new interesting technology and out there. It's more exploring science as a scientist, figuring out things that scientists have to interact with and how people have already done that. And so they can kind of come back and share that knowledge with us and kind of improve the younger generation of science. Am I allowed to talk about what episodes we already have?
Of course. Yeah.
So one of the episode, or the first episode I've recorded is on the chemistry GRE, or not the chemistry GRE, but the GRE as a whole. And that's something I thought would be really cool to talk about because I was very recently a graduate student and very recently had to take the GRE. And so I was at my school when some of the younger students were really spearheading the movement to remove the GRE as a requirement. And when they brought this up, it was just so cool to me. I was like, I didn't even think about the idea that we could remove it. It just seemed like it was something that was there and it would be there. And you hated it. You didn't see much of a reason for it, but you did it because you wanted to go to graduate school. And so seeing how those students really explored all of their options, that kind of embodied to me exploration science. And so for all of the episodes that I'm picking, I'm kind of thinking of it in that frame of mind. I will still, of course, look for very cool tech that we can talk about, but that's kind of how I view exploration.
I think it'll be very complimentary, and I'm really looking forward to all of your episodes and to season two and season three. And as I mentioned, I mean, I think people who are listening to this, like, we want you to let us know what topics you're interested in and what's out there.
Absolutely.
Because yeah, I mean, Deidre and I are obviously like science enthusiasts, but we don't see everything that's going on. So there's
Right.
obviously cool stuff that we're missing. So
It
yeah.
would be great if you tagged me in something on LinkedIn and said it would be like, if you should talk about this, I'll do it.
Yeah, I love it. All right. Well, again, welcome to Exploration Science, Deirdre. I'm super
Thank
excited to
you.
have you. And yeah, I'm just looking forward to season two.
I'm very excited. It's going to be a great season.
Absolutely. Thanks for tuning in to this episode of Exploration Science. As always, we welcome your feedback and suggestions for topics that you'd like to see covered. You can leave those suggestions in the comments below or tag us on LinkedIn. You can also find this podcast available as a YouTube series by searching Exploration Science. Thanks again for tuning in.